everybody, this video is about force. So we're going to focus on Newton's second law, right? So where you sum all the forces acting on some object, it's proportional to the acceleration, right? According to the mass. If acceleration is 0, then that object is in equilibrium. So, and then if the acceleration is 0 and the velocity is 0, then that's static equilibrium, which is the focus of this course. And given any statics or dynamics problem, you're going to follow these same steps to solve. So the steps, number 1, always start by drawing the free body diagram. Okay, draw the free body diagram. Then pick your coordinates. So this class, we're pretty much going to stick to Cartesian coordinates. In future semesters, we'll explore other coordinate systems. Then once you have your free body diagram and your choice of coordinates, then you write out Newton's second law, but you can decompose it according to the coordinates you picked here. So now you write Newton's second law, decomposed. For example, like that's a 3D vector equation, right? So instead of one 3D vector equation, you can split it into components. So say you pick Cartesian, right? So you split up the force into XYZ components. You split up the acceleration vector into XYZ components, like this. Right? So now instead of one 3D vector equation, you have 3 scalar equations. That's the benefit of Cartesian coordinates. Okay, and then last step, you just solve whatever math. Okay, so for example, let's say there's this car on a ramp and there's friction and it's static, it's just sitting there. So first step, draw the free body diagram, right? So here's the car, free of its surroundings, and then you draw all the forces acting on it. So there's weight, there's a ramp this way, right? So then there's normal to the ramp, and then there should be friction opposing the motion, right? Because the car would normally slide down the ramp. So friction is opposing the motion. Okay, let me just draw this twice for the next step to show different choices of coordinates. What I don't want to see is picking your coordinates first, then drawing the free body diagram. For example, like if you decide beforehand that you want to pick coordinates like this, and then you draw the car according to your choice of coordinates, right? Then it's kind of weird. Like that's not the orientation of the car, right? It's this way, and that's because you decided on the coordinates first and then drew the free body diagram. So that's backwards, right? Okay, so for these free body diagrams, how about 2 different choices? Let's say you pick coordinates like this. Right, that's pretty good. But then somebody else decides, oh, I'm going to pick coordinates like this. The strategy here is that we aligned one of the forces with a coordinate axis. This one, we got 2 forces aligned with coordinate axes, and that's going to make a difference on the final step when we're solving the math. Okay, but let's take a look at the geometry here though. Like, this is horizontal, this is the ramp, right? So that's right here, this is the angle. And then these are perpendicular, right, to each other. So that means if here to here is theta, that means here to here is theta. Right? And then similarly, here's horizontal, here's vertical. which of these is the angle? So you got to be like 100% sure when you do this geometry. Right, so for sure, this is the horizontal and then the ramp. So in your head, see this dashed horizontal and vertical coordinate system? Imagine just rotating the entire coordinate system clockwise. So right, so from dash to the red solid line, it's theta. From dash line to the red, theta. From dash to the red solid line, theta. From dash to red solid line, theta, clockwise. So it's like you're taking an entire coordinate system and rotating it. So remember that strategy. Okay, so then step 3, let's write Newton's second law decomposed. So we'll split it into the x and y components. So in the x direction, the x component of n is positive, and look, it's opposite the angle, right? So sine. The x component of the friction is negative, and it's adjacent to the angle. Right? And then the x component of the weight is nothing, 0. Okay, this is static. In the y direction, the y component of n is positive and is opposite the angle. Sorry, adjacent to the angle right here, right? So cosine. Friction here is positive y and is opposite the angle, so plus. And then the y component of the weight is negative. Okay, let's try this one now. So the x component, I picked the x-axis over here, right? So the x component of the weight is positive and is opposite the angle. Right, so opposite, so sine. The x component of n is 0, and then the x component of f is just negative. Right, and then in y, the y component of w, negative, and adjacent to the angle, negative. The y component of n is positive, and then there we go. Okay, so let's say you know the weight of the car. So the only unknowns are the normal force and the friction. Normal force, friction, right? So 2 equations, 2 unknowns. Now let's say you want to solve the math. Solve these 2 equations for 2 unknowns. Not too bad, right? Just do substitution. But solve these 2 equations for 2 unknowns. Easier, right? So your choice of coordinate can make that last step of solving the math easier. Okay, so let me know if you have questions. Thanks for listening. I'll see you on the next video.